Hi guys, it's Mr. Kilburn, and I'm going to go through an example of implicit differentiation and try to maybe explain a little better why we even need to put a dy dx within these equations, and just go through a basic example and help start to lay the groundwork for some more challenging ones that we're going to do in the future. All right, so first of all, so this is an implicit function. Okay, x's and y's are mixed together on both sides of the equation. It's not just y equals, which would be explicit, like this. Like this would be an explicit function, 3x squared plus 5. Okay, it would be a parabola compressed a little bit, shifted vertically up 5. Okay, now, if I said, what's the derivative of this function, you would just say y prime equals 6x. You probably wouldn't think much about it. All right, but remember when we first talked about derivatives, one of the notations that you'll see once in a while coming up, especially with related rates, one of the notations is Leibniz notation, okay? And you've seen it, dy dx, something like that. So basically, we've been doing that. Maybe we just haven't showed that same notation, all right? So here's what I mean. I'm going to take the derivative of this now using this exact notation. All right, so let me get rid of this also. Okay, with equations, whatever you do to one side, you've got to do to the other. Whether you're adding 4, dividing 5, whatever you do to one side, you got to do to the other. And that includes derivatives. So if I take the derivative of both sides, okay, like this, here's what's going to happen. You can think of the implicit piece of this as almost like a chain rule. All right, the derivative of y is 1. Okay, so the derivative of the outside, it's almost like, suppose you saw this. All right, it's almost like a mini chain rule, power rule put together. So watch this. If I take the derivative of y to the 1, right, the 1 would come out front. I'd get y to the 0. And then what is y to the 0? Anything raised to the 0 is 1. Okay, so the derivative of y is 1. Okay, that's the outside. The inside is just that y. All right, well, the derivative of y with respect to x is dy dx. Okay, that's why we even put it on there. So it's like I said, it's like a chain rule, or it is a chain rule, I should say. Excuse me. So the derivative of y with respect to x in this case is just that. It's dy dx. On this side, it's only in terms of x. So the derivative of 3x squared is 6x, but I'm not going to put dx dx. Okay, the derivative or the change in x with respect to itself, or the change in x over that exact same change in x, they would just cancel out anyway, and you'd get 1. So we don't put that down. So when it's defined explicitly, you don't need to put down dx over dx. It's just, that would cancel. All right, and the derivative of 5 we know is 0. All right, so there you go. When defined explicitly, you could write it like this: dy dx equals 6x. The derivative of y with respect to x is 6x. It's when you have maybe different powers of y and x's and y's mixed together on the same side of the equation. It's not defined y equals explicitly. And that's when you need to tack on a dy dx whenever you take the derivative of a term with a y in it. All right. Hopefully that helps. So let's go. Let's work through this example. It's not a super long one. Here we go. So the derivative of 4y squared, okay, is 8y dy dx. The derivative of 3x is 3. The derivative of negative 1 is 0. The derivative of 7x squared is 14x. Again, I don't need to put dx over dx. It just cancels out anyway. And the derivative of y with respect to x is dy dx. Okay. I want all my dy dx's on one side, everything else on the opposite side, and solve for dy dx. So what I'm going to do is I'm going to subtract 3 to both sides, move that over here. Subtract 14x to both sides, move that over there. Okay, so when I rewrite this, I would have 8y dy dx. Again, this is going to come over here, minus dy dx equals 14x minus 3. Now these two terms on this side of the equation both have a dy dx in it, so I can factor out dy dx. That gives me 8y minus, well, dy dx multiplied by what gives me dy dx? Just 1. Okay, now I can divide both sides by 8y minus 1. And I get dy dx equals 14x minus 3 all over 8y minus 1. There you go, guys. There's implicit differentiation, taking the derivative of y with respect to x. When you take the derivative of that y term, tack on a y prime or a dy dx. And at the end, as you're getting close to the end, you're going to get all your dy dx's to one side, factor it out, and once you get dy dx equals, then you have the derivative of y with respect to x. And it's going to have more than one variable in it. That's okay. That's the way it works. All right, guys, have a great day. Talk to you soon. Take care. Bye-bye.